In the dust, we found what we characterize as unreacted thermitic material in the shape of some very tiny red-gray chips. And in the reaction they produce molten iron, which is the prime indication of a thermitic reaction. And such a reaction can be used to destroy steel structures. What we have found is a modern version of thermite, which we call nanothermite, which is produced in a different way. It is not just two powders being mixed. The material is actually built from the atom scale up. We call it the bottom-up procedure, which is what you do in nanotechnology.
It is the small size of the particles involved in this material that allow us to characterize it as nanothermite. In ordinary thermite, the particle size is much larger, and hence ordinary thermite is an incendiary, whereas as the particle size becomes smaller and smaller, it can become explosive. Super thermite is sometimes called.
And we found that the composition of these microspheres, of these very small spheres, many of these spheres had the exact or identical composition or very similar composition as the spheres that Steve was finding in the dust samples. They were also very similar to spheres found in thermite, in commercial thermite. Once you ignite commercial thermite, you also get microspheres. And the composition was very, very similar. And that led to the conclusion of the paper, which was, we've got some form of thermite in these red-gray chips. These particles that are in the red layer are thousands of times smaller than, say, the width of a human hair. So these are very sophisticated particles, very sophisticated materials. In order to get that kind of consistency with shape and size and to be that small, these really are sophisticated materials and probably only developed in a laboratory.